All right, let's get right into it. Today, we're going to look past all the usual buzzwords like encryption and security and really dig into what data privacy is all about. And trust me, the difference is a really big deal.
You hear the word secure thrown around all the time, right? Secure servers, secure payments. But here's the question that really gets to the core of this whole topic. Just because your data is secure, does that automatically mean it's private? Well, the answer isn't as simple as you might think.
Okay, to really get this, let's use a simple analogy. Think of information security like the lock on your front door. Its entire job is to keep uninvited people out. Simple. But privacy? That's more like the curtains on your windows. It's about controlling what the guests you've already let inside are allowed to see. So one protects the house itself, the other protects your personal space inside it.
And this very same idea applies directly to how companies handle data. The whole mindset is shifting. It's moving away from just protecting the fortress, the company's servers, to protecting the actual people the data is about.
So let's break this down. On one hand, you've got Information Security Management, or ISM. Its main goal is to protect the company's information assets. It's all about the classic CIA triad: confidentiality, integrity, and availability. But Information Privacy Management, IPM, has a totally different goal. It's focused on protecting personal data and the rights of individuals. It's about making sure data is collected and used legally, ethically, following rules like GDPR or HIPAA. So it really just boils down to this. Security protects the data, privacy protects the person.
So if privacy is all about protecting people, then just sitting back and reacting to threats, well, that's not going to cut it. We have to get ahead of them. And this is where we see a huge shift from a defensive posture to one that's all about smart, proactive design.
Which, of course, brings us to the big question. How do we actually do that? How do we move from just cleaning up messes to preventing them from ever happening? How do you spot a privacy risk before you've even launched a product?
Well, the answer is a really important tool called a Privacy Impact Analysis, or a PIA. Think of it as a formal process, kind of like a blueprint that companies use to map out and reduce privacy risks from the absolute beginning of any new project.
And let me be clear, this is not just some optional nice-to-have thing. A PAI is often legally required. A company has to conduct one anytime it's planning to collect sensitive data. We're talking health info, biometrics, or if it's introducing new tech like AI, sharing data with other companies, or doing any kind of large-scale monitoring. It's really the first step in innovating responsibly.
But running a PIA is just the starting line. The real endgame is to weave privacy into the very fabric of everything you do. And that leads us to this really powerful principle called privacy by design.
Privacy by design, P by D for short, is pretty much exactly what it sounds like. The core idea is that privacy can't be an afterthought. It can't be a feature you just bolt on at the end. It has to be built right into the architecture of your systems and your processes from day one. It makes privacy the default, not the exception.
And I guarantee you've seen this out in the wild. End-to-end encryption and messaging apps? That's privacy by design. How about those websites where the cookie banner is already set to reject all? That's it too. Or think about Chrome's incognito mode, which is literally designed to forget what you did. Or browsers like Brave, which are built from the ground up to block trackers. See? In every case, privacy isn't some setting you have to dig for. It's just built in.
Now, this whole approach of building with privacy in mind, it's led to some absolutely mind-bending technologies that let us work with data without ever actually having to see the data itself.
Okay, check this out. Searchable encryption. Imagine you have a bunch of encrypted files stored in the cloud. This technique lets you search for a keyword inside those files, and the server finds what you're looking for without ever decrypting anything. The server never knows what you searched for, and it never knows what's in your files. You get the convenience you want with total privacy.
Now, that's amazing for an individual, but what about for entire organizations? Picture this. You've got three huge rival companies. Let's call them TCS, Infosys, and Wipro. They want to figure out the total number of security threats they've all seen, but there's no way they're going to share their private numbers with each other. It's a classic standoff. So, how do they get the total without giving up their secrets? This is where a cool technique called secure multi-party computation comes in. Here's how it works. First, each company takes its secret number. So TCS has 30 events, Infosys has 50, and Wipro has 20. Then, they each split their number into 3 totally random, meaningless pieces. We'll call them shares.
Next up is the exchange. Each company keeps one of its own random shares and sends the other 2 shares to its partners. So now, everyone is holding 3 random-looking numbers, and here's the key. Nobody has enough information to figure out anyone else's original number. The secret is still safe.
All right, now for a little bit of math. Each company takes the 3 shares it's holding and just adds them up. So TCS gets a local sum of 39, Infosys gets 32, and Wipro gets 29. On their own, these numbers are still completely random. They don't reveal a thing.
And now for the magic trick. The companies openly share these new local sums with each other. And when you add them all together, 39 plus 32 plus 29, all of those random numbers that used to hide their data perfectly cancel each other out. And what's left is the true total. 100, exactly. They got the number they all needed, they were able to collaborate perfectly, and not a single one of them had to reveal their private, competitive information. That right there is the power of modern privacy engineering.
So after all that, what's the big takeaway here? Why does this whole distinction between a lock on the door and curtains on the windows actually matter to you and your data?
It really comes down to this. Real data privacy isn't just about building higher walls or stronger defenses after a product is already out there. The real future of privacy is in proactive design. It's in building our systems from the ground up with a deep respect for individual rights baked right in.
And that kind of leaves us with one final thing to think about. As we're barreling towards a future with AI and the metaverse and all sorts of new tech, what new privacy challenges are we going to face? And more importantly, what new rights will we need to design into the very fabric of this new digital world?